If time zones were divided evenly, which they're not, because they're divided politically, culturally, they'd be 15 degrees wide. If you do the math, 15 degrees times 24 time zones gets you 360 degrees. Now, you may have noticed, if you look at a globe, that the lines of longitude that separate out, as you get near the poles, they come closer together. Ooh. So you don't have to travel as far to go from one time zone to the next, because they get narrower and narrower. As you get near the North Pole, all lines converge to one point. So the question is, what time is it on the North Pole?
No time or all time, right?
That's as good an answer as any.
Nice.
It is all time on the North Pole.
But
you know what an egg is?
A cell.
No, I was going to be more metaphorical.
Oh,
Okay.
What's an egg? What's an egg?
This is not a biology class here.
I'm sorry.
An egg is a spacesuit for the unborn organism so it can survive in an environment that would otherwise kill it.
Yeah, it is.
Until it can survive, then it no longer needs the spacesuit. The chicken is inside the egg because the outer environment can't live in that environment. So it stays in there until it's ready, then it pops out and it can lead the ship.
Earth plows through 200-300 tons of meteors a day. This is debris that is in the way as we move in our orbit. By the way, this includes all the shooting stars you see at night. You add all those up, a couple of hundred tons a day as we orbit the sun. Ask how much total mass is there that we could sweep up, and compare that to the mass of Earth itself. If you do that, it is a mere pittance of our current total mass. So you can declare that we dominate the mass of our zone. Pluto does not. You can calculate how much mass is there for Pluto to interact with. It's factors greater than the mass of Pluto itself.
Here's something interesting. Ready? You know who the smartest person in the world was? The first person to figure out you can build a ship. Everything you make the ship out of is denser than water and it can float. You can build a ship out of steel and have it float. It changed warfare. You don't have to build your boat out of wood, which is susceptible to cannonball fire. You can build it out of steel. How do you get it to float? Because the part of the boat that sits below water is mostly air. The hull of the ship sits below water. So what matters is not that steel is heavier than water and air is lighter than water. It's what is the average density of that which you have plunked in the water. It's the total volume divided by the total mass. It has less mass than you think because most of it is air. Santa can't be real because if you add up how many Christians there are in the world and give him 24 hours to deliver gifts, how fast his reindeer would have to move, he would vaporize in the atmosphere. If you have your hair when you're 30, you'll probably have it for the rest of your life. That's how that goes. You start losing it going up until you're 30. You can say, well, the hair follicle begins to not producing the keratin or whatever. We get the explanation. Then you say, well, why does the hair follicle stop doing that? Then you say, oh, well, because the DNA has it pre-coded about the hair kind of thing. Well, why does the DNA have the hair? Well, because it...
Right, but we know far more about how and why people go bald than we do about what gravity really is, correct?
I'm telling you, gravity really is the curvature of space and time. That gets us the Big Bang and everything we've ever known and
Curvature of
loved.
space and time, but it's also based on mass, right? Based on the amount of mass.
Any
and
concentration of
mass.
matter and energy will curve the fabric of space and time. And the
more
movement
gravity.
of matter on that fabric of space and time, we call gravity.
Can you explain how they measure time? It's an atom that blinks 1 billion times in a certain amount of time, and that equals a second.
Oh,
is
yeah.
that right?
Okay. We can go there. You ready?
Yeah.
The length of a second, up until I think it was early 1960s, was defined by a specific fraction of the duration of the year 1900. And the rotating Earth is a key part of this measurement. Your measure of time is based on the rotation of the Earth and the time it takes Earth to go around the sun. If those things change, you will never know that because that is your yardstick. If your yardstick is changing, you will only know that if you have another yardstick to compare it to. We offloaded the measurement of the duration of a second to atomic vibrations. There's a transition, what we call an electronic transition in the cesium atom, where you can measure the vibrations of that in the laboratory. And the duration of a second was defined, and it has been defined that way for the past 60 years. When we did that, we said, hey, Earth is slowing down. For the first time, we could just measure that. Not only that, earthquakes can change the rotation rate of the Earth, and melting glaciers, because it changes where the mass is on the Earth. It's no different from a skater who's spinning, and then they bring in their arms and they spin faster. They change where their mass was in their rotating body, and it affected the rate at which they rotated. If you have earthquakes, they can shift plates continental plates to different parts of where Earth is, affecting our rotation by a very tiny amount, of course. Migrating animals from north to south, south to north, also affect. But the biggest effect is the tidal sloshing on our shores. And we put in 23, 24 leap seconds since then.
And so as polar ice caps melt and there's more water, we're going to slow down even more.
Yes,
right?
only because the water that's in the poles, as that melts, it goes back into the ocean, and then that water can move now to the equator. Right. So that's mass going away from the rotation axis. So if you ever see skaters, they bring in their arms, they spin faster. Well, how do they stop spinning? You don't know this, but they return their arms to an outer position. This slows down their rotation. It looks like they're just posing for the photo, but if they didn't do that, they would keep spinning.
Will the Earth ever stop spinning then?
No, so these forces acting on the Earth, 7 to 10 billion years, it's slow. The sun is long dead by now, okay? So this is just a theoretical exercise. The moon is slowing down Earth, and it will do so until we only show one face of Earth to the moon. We did that to the moon. We slowed down the moon's rotation, so it only shows one face to us. That's why there's a near side of the moon and a far side.
What's the scariest place in our solar system? The worst place for us, almost all of it actually, beyond Earth, is horrible for us. It's almost like where is somewhere that isn't scary. We couldn't exist anywhere unprotected, anywhere from, about 35,000 feet upwards or less, right? From the top of Everest upwards. And then if you go underneath the water, right? So for us, if you go just a little bit down in the Earth or a little bit up, there's a narrow band which is not scary for us, and everywhere else is horrible. Amongst the worst places are the sun. The sun's really not very nice. No, all of it. It's all absolutely terrible.
We have no idea, unless you're religious and you have a strong belief ethic in that, we have no idea what happens after death. Nothing can be spookier.
That's right. And even those belief systems cannot be confirmed in any sort of experimental strategy.
Right.
People have tried. As you know, they're even expressed in fiction, like Dan Brown's novel, Angels and Demons. There supposedly was an experiment where they had somebody who was about to die and weighed him, and then he died, and they weighed him again, and it's a little lighter. Some sort of physical thing,
they even
like
tried.
A soul.
And you got to give them credit for doing the experiment.
You got to try.
Yeah. So if everyone thinks you have a soul, and there's science that can test things, why not test your soul? Right after Wilhelm Röntgen discovered X-rays. X-rays can see through your body. No one else ever saw through your body.
Right.
Now X-rays. So they get somebody dying on the bench, and they waited for him to die to see if they saw something leaving his body with the X, and they didn't.
They did not.
Yeah.
That's right.
How much do you weigh in water? Zero. You're neutrally buoyant. So in water, we don't weigh anything. Put a scale in water and stand on it and read it, okay? That's what I'm saying. Okay. So when you don't weigh anything, then structurally, you're not putting yourself at risk. And that's why the largest creature there ever was is a mammal, and it lives in the ocean. It's a whale.
Right.
The blue whale. So when they say, how much does a whale weigh?
Right.
The answer is zero. They give you a weight. And how do they give you a weight? They take it out of the water, put it on a scale on dry land, and then it weighs, a gazillion tons, but that's not the weight that the whale feels as it moves through the ocean. While you are firing rockets, there is a force operating on you that you will not be able to distinguish from an ordinary gravitational force. This was deduced by Albert Einstein in what's called the equivalence principle. An accelerating rocket is indistinguishable from you sitting on Earth with Earth's acceleration of gravity. There's no experiment you can perform other than looking out the window to know if you're in a rocket or sitting here on Earth in a box. What's that movie that had moon pirates? Seriously?
Oh, that was called Ad Astra.
Ad Astra. So they would show these rockets firing, and you go inside the ship, and they were all weightless. No. There's this misconception that being in space
makes you weightless.
No,
right.
No. If you are drifting in space, as our space missions do, they're sent in motion and you're drifting towards the crossover point, you're weightless that entire time. But as long as you have on rockets, you are not weightless. The fastest spaceship we've ever launched, if you aimed it for the closest exoplanet, let's go to Proxima Centauri. It's called Proxima
B.
because it's close. It is 4 light years away. Proxima Centauri, right there. Aim your fastest thing we have ever launched. Take you 70,000 years. So you got to figure out how to defy your biology or invent a wormhole. And I'm gonna bet on the wormhole. Mercury's orbit is not following what it should. That's the closest planet to the sun. Well, we've been down that path before. Just throw in another planet that we can't see, and that'll fix it. Thus was introduced planet Vulcan. This would be a planet very close to the sun. So close it would be hard to see, it'd be lost in the glare. No one found it. Einstein comes up with his theory of motion and his theory of gravity, which are corrections to Newton's laws
because in these extreme regimes, if you're near the sun has very strong gravity. If you're moving around in that strong force of gravity, Newton's laws begin to fail. And you look at Einstein's laws, and he says, Mercury's orbit will not follow Newton's laws, it'll follow this other path. And it exactly explained the deviations of Mercury. And so people say, oh, see, scientists, we thought this was right, and now we all huddle around this thing that's right. No, the way it works is if you have an experimentally determined result, and it's verified, and double-checked and triple-checked, that will not later be shown to be false. What you can find is a deeper understanding that encloses that understanding.
Did you see the movie, what's the one with Scarlett Johansson, and her brain power is increased? Is it Lucy? Lucy, yeah. The entire premise of that film is that the 90% of the brain that you're not using. Well, where did this whole premise come from? It comes from some guy 100 years ago or so. What he published was, the brain is so complex, we know only what 10% of it is used for. That's all he said. A completely innocent comment. We have much more to learn about the brain. It got re-quoted as, we only use 10% of our brain. This is the mantra for teachers with students. It's a very hard thing to correct when saying it incorrectly is what you want to hear.
Why do you think we want to hear that?
Because we want to believe that we all have potential we can grow into. We don't invite China to participate in the International Space Station. They were disinvited. We invited Russia because they're brilliant people in Russia who were working on space. We don't want them to go to our enemies, whoever they were. Bring them with us, then they are our allies. There's no China. What were the reasons? Oh, human rights violations. I have no evidence for this. Someone somewhere said, if we disinvite China, we know they're gonna do this on their own. They're gonna make their own space station. They're gonna put their own people into orbit. They have the resources, their economy was on tear. They're gonna do it. And that'll spook us into redoubling our space efforts because now we have a new adversary to replace the Soviet Union, which is the role they played when we went to the moon. So fast forward 15 years, and what do we have now? China says they want to put astronauts on the moon. Oh, we have the Artemis program, returning to the moon.
What's something you learned recently?
I think I knew this when I was a kid. If you're playing basketball and you're shooting, and you say, oh, that didn't go in, oh my gosh, well, the rim, they should maybe make the rim a little bigger, I could score more often. Do you realize 2 basketballs can fit exactly side by side through the opening of a basketball hoop? It's not a cosmically mind-blowing moment, but that gives you perspective next time you watch a basketball game. It's how these guys can fly from the foul line in an airborne slam dunk and not miss because the area of this opening is 4 times as large as the ball itself. Not that that's easy to accomplish, but knowing this, you realize how much easier it is to score than you might have otherwise thought. And I got in big trouble one time. December 25th, I tweet, on this day, long ago, a child was born who by the age of 30 would transform civilization. Happy birthday, Isaac Newton. Born 1642. Boy, that pissed off a lot of people. It pissed off some people. And it's odd because Isaac Newton was actually born, on that calendar, he was actually born on that date. When no one knows what day Jesus was born, right? So people are angry with me for saying something true. The consumption of oil is not fully priced into the price of oil. So, for example, when roads were built, our tax money built roads. That enabled car companies to sell cars. If the price of gas contained the cost of making all the roads to drive the car on, it would be way higher than anything we ever paid for it. And then you'd see the true cost to you of using that technology, the internal combustion engine. So the actual price of things are kind of hidden within various sectors in society. So Stephen, will we ever have the ability to travel backwards in time? I'm thinking not, simply because if we ever did obtain that ability, we would have met somebody by now from the future.
One might hope that we could warp space-time so that one could go off in a rocket and come back in the past, but I have shown that this is not possible. If energy density is always non-negative.
Maybe that's a big if. All we have to do is create negative energy density stuff. Then we'll all be able to travel backwards in time.
Most of us physicists believe that time travel to the past is not possible, but we've not ruled it out definitively with our mathematics. In fact, there are some proposals on the table using exotic things like wormholes, in which people have proposed schemes for traveling to the past. Most of us believe that when we understand physics better, all of those schemes will fall aside. They won't be compatible with our more refined understanding of physics. But as of today, time travel to the past, the door has not been closed.
Leeuwenhoek, the microscope guy, he got a drop of pond water, puts it under his microscope just to think to do this. It's just water. Why do you think that's something interesting to do? He said, I wonder. He was curious. He puts it under and sees little, what he described as animalcules, happily a-swimming.
Animalcules.
Animalcules. These are like the amoebas in paramecia. He reports on this to scientific authorities, and they don't believe him. They say, Van Leeuwenhoek, we think you might have had too much gin before you wrote this letter. Why would anyone believe this? That there's entire creatures, an entire universe of creatures thriving in a drop of pond water. So the way science works is one report does not make it true. You need verification. They sent people to the Netherlands to verify his results, and there it was, the birth of microscopy. And then they looked at everything. One time I had dinner with him. I asked him a question. He's typing out replies with his eyes on his device. And I said, how come Isaac Newton didn't figure out how to stabilize the solar system, and he needed Laplace to figure out perturbation theory to show that every time a planet goes around, it's not tugged out of its orbit by Jupiter? Because Newton was upset about it. He didn't know. He didn't have an answer.
Right.
In fact, he credited God for coming in and fixing things every now and then. So I posed that question to him. And then 15 minutes later, out comes the answer. You can't think of everything.
I know, that's great.
That was a dewdrop of wisdom. And then he went on to say, Einstein didn't think of black holes. People got Nobel Prizes off of black holes.
Why do I slow down as I approach the speed of light?
Now you want to freak out? You know, I don't want your head to explode. You ready? The faster you move, slower
That's
time
what you
takes
just said, yeah?
for you,
Yeah.
as seen by others. As you approach the speed of light, time continues to slow down.
Yes.
At the speed of light, time stops, which means for a photon moving at the speed of light, when it is absorbed in your retina, it is the same instant it was emitted at the Big Bang 14 billion years ago.
That's what I thought.
The photon gets emitted, bam! It's in your, as far as it's concerned, it is in your eye in that same instant.
Can we measure that photon and
Yes.
observe the Big Bang?
I know that came from the Big Bang, and I'm watching it, and it's taken 13.8 billion years to reach you, but if you are that photon, it does not experience that time delay. No, you're not going to have weapons destroying satellites in space. You know why? Because you do that, your satellite becomes hundreds or thousands of pieces of broken hardware moving at 18,000 miles an hour that can take out your own satellites. It's the modern equivalent of trying to use mustard gas because you can't shoot the soldiers in the trenches. Let's do a mustard gas. Oh, the wind changed. Oh my gosh, now it's coming back in our face. So space warfare is not so much weapons, but access to information. And the Second Gulf War was completely enabled by space assets. When we were all in the caves, half of everyone born was dead before the age of 30. Fast forward to 1840, that number went up to 35. Half of everyone born was dead by the time they were 35. So, in the tens of thousands of years between living in caves and the middle of the 19th century,
we only got 5 more
we got
years.
5 years
Jesus.
on that. By the way, everyone back then was eating organic. Just saying. And the water was clear, the air ran pure, the game was free range. Didn't make a damn bit of difference. Science matters here. You can run around and eat all the organic you want.
Okay.
You'd be dead by the 30 unless some doctor came in and said, we can increase your life expectancy using science. One of the most depressing things I learned, Saturn's ring system might just be temporary.
Why?
Because they track the orbits, and the orbits are not stable. You're losing them down into Saturn itself. Gravity is pulling them in.
And when do they anticipate when that might happen, that those rings disappear?
They
Projection?
suspected that it's a 10 million year lifespan, which would mean the dinosaurs, if they had telescopes, Saturn would not have rings for them.
I'm going to miss those rings.
Visit Santa Claus. Santa Claus on the North Pole. And you say, Santa, which way is north? And every direction Santa points is due south. Because on the North Pole, the question, which way is north, has no meaning. You can't even go east.
Everywhere
or west.
you point is south.
Correct. So on the grid that we've all agreed that we use to establish coordinates of Earth, Santa Claus can only go south. Do you know about Santa's reindeer? Do you know about them?
Sure, I know very much about them.
Oh, you do?
Yeah.
Okay, so do you know that...
They're caribou.
Yes, well, yeah, caribou, correct.
Yeah.
And, well, you can domesticate the caribou. And when you do, then both the boys and the girls have antlers.
Well, that's just the fact of all caribou.
Oh, all caribou, excuse
Yeah.
me. But sorry, the domesticated ones are called reindeer. They're derived from the caribou, correct. So now watch what happens. So, as you may know, the male deer lose their antlers in late October, early November. The female don't. So all that means is all 8 of Santa's reindeer are female, which means Rudolph has been misgendered.
Interesting.
fascinating.
Do you know where the myth of Santa's reindeer flying comes from?
I think it's from mushrooms, isn't it?
Yeah, Amanita muscaria mushroom, which
Yeah.
looks like Santa Claus.
Yeah, with the red and white
And
dots.
they love those things. They love the Amanita muscaria mushroom to the point where when people are doing mushroom ceremonies and they go outside to urinate,
to drink the pee.
caribou will knock you over to get to your urine.
We're not made of rare stuff. If we were made of like an isotope of bismuth, then you could argue that this is a rare thing we got going here on Earth, and it's precious, let's not take it for granted. But we're made of carbon and nitrogen and oxygen, and this is like the most common ingredients in the universe. And if biology as an inevitable trajectory of the experimentation that happens naturally on planetary surfaces, then maybe life is inevitable, but is intelligence as we define it inevitable? So these are fascinating questions that require that we relax the bias that we have as being humans on this planet, just to even ask the question in an answerable way, are we alone? In the day, you could get radio stations from cities that were far away, but you wouldn't get TV stations. TV waves, you have to be in a direct sight line to the television transmitter. So you have to have a transmitter everywhere for TV. So TV was very local in the day. Radio waves, its waves had the right frequency to reflect off the ionosphere of the Earth. It could send a signal beyond Earth's horizon. These modes of communication had leakage, especially television waves. So someone eavesdropping on Earth, and they're, let's say, 80 light years away, you're getting the earliest radio signal that have been emanating from Earth at the speed of light. And then the TV signals would start coming in, early TV, and they'll see the war broadcasts and everything. They get to the 1980s and signals start disappearing. People are using cable. So a lot of what's happening today is protected from leakage. In Ramadan, you fast during the day and you get to eat at night. So it's 40 days of fasting, I think 40. Wow. Well, it turns out I was recently in Dubai where they have the tallest building in the world. And I did a quick calculation and I confirmed it with others there that in fact they print separate tables for residents at the top of this building because the sun sets 2 minutes later if you are at the top of that building than if you were at the base, because you're seeing that much farther over the curvature of the Earth. Do you know the pyramids in Egypt? They stopped building pyramids. I don't know if they ran out of pharaohs to build pyramids to or they ran out of money. One day they stopped. Do you know what year we built something taller than that pyramid after that pyramid was built? It was in the Paris Expo. The Eiffel Tower was the first object we ever built as a species taller than the pyramids. So just because you're doing something in one period of time doesn't mean it will continue forever. In fact, my great fears is that you end up taking it for granted. There's a strong religious tradition to say a prayer before a meal. Why? I ask myself that. And I realized that most of the history of civilization, you really didn't know when your next meal was coming. Food was a cherished commodity. And so if you had food, you were thankful. Nowadays, if you have food, you say, no, I got to go to the gym and work this off. Yeah. You can't pull an orange off the stack in the grocery store without the whole pyramid spilling out onto the ground. America might be the only country with overweight homeless people. Then I thought, if you're going to pray today, what might you pray for if you were to change that ritual to something that was cherished or rare? And I'm thinking maybe you should pray for yourself to understand objective truths, because that would be the foundations of the advance of civilization. I went to Antarctica for 2 weeks, and it's like penguins hang out in Antarctica. It's their country. They don't care about you because they don't have any land predators, so they don't think you're dangerous. And I had this hypothesis that if they did have land predators, they wouldn't be so clumsy. Because they're tripping over each other. And I'm saying, y'all have nobody chasing you. Because if you did, you'd be way more graceful on the land. Penguin is the only bird that can swim but can't fly. And they live it all in their own poop, which is weird. And there's like thousands of them. And as you get near them, the smell is there. And I'm thinking maybe they tell each other apart by the smell of their poop. I don't know. It is not an accident that there are 7 days a week. Each day of the week is named for one of those 7 planets. To the ancients, there were 7 planets. Sunday is named after the sun. How about Saturday?
That'd be Saturn.
Saturn. How about Moon Day? Guess what Moon Day was named after?
But now that works as
Tuesday, planet Mars.
Why are you trolling me?
Okay, all right. So let's go back to the Romance languages. What do they call Tuesday? Martes. It's Mars. So we now have Norse mythology joining in Wednesday. So what's Wednesday in Spanish? Miércoles, which would be Mercury. Thursday, we all know who that's named after. Thor. It's Thor's day. Who in Greek mythology wields lightning? Jupiter. Friday, named for Venus, the goddess of love and beauty and all that.
They all track back to the seven planets.
right.
Correct.
You realize, old timers, we grew up, if you called someone Neanderthal, that was an insult. Do you realize that the most racist scientific community ever were 19th century anthropologists? They're the ones that set up the race and the this, and white male humans were at the top of the evolutionary ladder, and blacks and everybody else were lower, still evolving, closer to the apes. So watch what happens. In the 1990s, now that we can do genetic tracking and things, the world found out that Europeans are between 1% and 3% Neanderthal, and Africans are 0% Neanderthal. So in the 1990s, research papers started coming out talking about how creative and imaginative the Neanderthals must have been, and how they used a complete facelift of the Neanderthal.
What's the most important thing that most of us don't know about the universe that we should?
For me, it's the greatest gift that modern astrophysics has given civilization. In 1957, a research paper was published, including a leading female scientist, by the way, who's under-celebrated. Her name was Margaret Burbidge. They published a paper demonstrating that the atoms in your body, the nitrogen, the iron, the carbon, that all of this are traceable to cosmic crucibles deep in the centers of stars. It manufactures them by thermonuclear fusion. The star explodes, scatters that enrichment into gas clouds that make the next generation of star systems, such as we. So it's not like you're out in the universe looking up and you say, yeah, I'm alive in this universe, but I feel small. No, the universe is alive within you, and you should feel large. That revelation that we are not poetically, but literally stardust, borders on the spiritual. And I think everyone, it is their duty to know that.
What's the most mind-blowing thing you can tell me that's true?
In 1 centimeter slice of your lower colon lives and works more microbes than the total number of humans who have ever been born. Which means to them, all you are is a darkened vessel of anaerobic fecal matter. Yet we tell ourselves that we're in charge. If you upset those microbes, they're in charge because you know your distance to the nearest toilet. So this is a cosmic perspective of a biological sense, where you want to think you're important and you are not as important as you want to believe you are. However, the ingredients of life itself, the hydrogen, the oxygen, the carbon, the nitrogen, they're forged in the Big Bang and in stars themselves. The fact that we are carrying the elements, we are not just figuratively, but literally stardust. And it's not simply that we are alive in this universe. The universe is alive within us.
Modern nukes don't have the radiation problem.
Really?
Yeah, it's a different kind of weapon than the Hiroshima and Nagasaki.
Nuclear weapons, if they're exploded, don't have a radiation problem?
Not if it's hydrogen bombs. No, not in the way that we used to have to worry about it with fallout and all the rest of that. What you really have to worry about is being vaporized, and after that, if you're not vaporized, blown to bits by the shockwave.
A lot of people are worried about is, and I've heard this about India and Pakistan also, if they exchange their nuclear weapons, that the radiation in the atmosphere would come over here, would go all over the world, even if it was just a local exchange. Now you're telling me that is not a worry?
If they use fission bombs, yes, that would be the case.
Oh, for fuck's sake.
Just in case you were wondering, in a mirror, you can only kiss yourself on the lips. Just saying.
Thomas Malthus, who said population will outstrip food supply because population is growing exponentially and food is only growing arithmetically, so we'll all starve to death one day. And he had no idea that science would be brought to bear on animal husbandry and plant crops. Yes. If things kept the way they were back in 1780 or whenever he wrote, yeah, we'd all be dead now. But we have innovations, we have creative people who say, I don't want to die, so let me figure this out. We now have more food grown on less land by fewer people than ever in the history of civilization. The fact that people are starving in the world is not because there's not enough food, it's a distribution political problem. It's not because we're running out of food. Any animal that we have ever got to study in more detail than we previously did has shown to be more intelligent than we ever gave it credit for being. Yeah. And you know who has the biggest brain to body weight ratio of any creature on Earth? Some species of ants. 15% of their body weight is their brain. And it's kind of obvious. Some of them, like the whole front section is their head. In retrospect, it's kind of obvious. And ants are very busy doing some complicated things and we don't know what they're doing.
Especially leafcutter ants.
They're busy, carpenter ants, leaf-cutting ants, and cross over into termite land. They're busy building stuff.
And they work in communication with each other
And they
somehow.
communicate. And to say, well, we're at the top, really?
Here is 90% hydrogen. Can we tell if it's a failed star?
Had it been maybe 5 times more massive, it would have been a star, and we would have had a double star system.
Why does that size suddenly make it a star?
Because the bigger you are, the higher the pressure is in your core, because there's more mass, there's more weight, there's more pressure. And when you have pressure in the core, the temperature rises. And as the temperature rises, there's a threshold where you start fusing nuclei in the presence of heat. Thermonuclear fusion. The sun is undergoing thermonuclear fusion in its core. The high pressures, high temperatures are squeezing together hydrogen atoms, and out the other side comes helium atoms. And the helium atom has less mass than the hydrogen atom. Where did the mass go? E equals mc squared. It became energy. And that energy is sustaining the star.
What do you think is the most extraordinary scientific mind that we've, that humanity has produced?
There is no contest. Isaac Newton. Nothing, nobody comes close.
Explain what?
He, working alone, discovers the laws of motion. Then he discovers the law of gravity, universal law of gravitation. Oh, and then someone asks, why do your planets orbit in this shape, ellipses, the ovals, rather than perfect circle? It's, I don't know, I'll get back to you. And he goes home, and he comes back, I finally have my answer. And they say, well, Isaac, how did you do that? Well, I had to invent integral and differential calculus to answer that question. He then discovers the laws of optics, deducing that white light is composed of colors, because you could take those same colors, recombine them, and get white light. So he does all of this, then he turns 26.
You've seen that thing on Jupiter, that storm that never quits. Isn't it suspicious to you that a storm there could go on for 350 years without a break, and we never have storms that go on for 350 years without a break?
So, first of all, when we have storms, it's in our atmosphere. We rotate once a day, and so that rotation creates what we call a Coriolis force. The Coriolis force is heightened if you spin faster. So what is Jupiter? It's 1,000 times bigger than Earth. It's mostly gas, and it rotates once in about 10 hours. You want to talk about ferocious Coriolis forces? We have storms that last weeks here, hurricanes that pick up on this little speck we call Earth that has this much atmosphere on it. Go to a planet that rotates twice as fast, is 10 times as wide, 1,000 times the volume, and is mostly gas, and you're complaining that it lasted 300 years?
You are really good.
Why is time different on different planets like in Interstellar? So that's an easy question to answer. It's Einstein's theory of general relativity. As you come closer to a planet, then your time, so let's say you have a watch and you look at the watch, then you'll see the watch tick at the normal rate, 1 second per second, and you won't see anything unusual. But from the perspective of someone far away, that watch will be ticking more slowly than their watch. And it's really to do with the distortion of space and time in the vicinity of the planet. So the general rule is if you go to something that's very massive, you approach a very massive planet or even a black hole, then as you go there, from the point of view of someone far away, they will see your time tick more slowly.
Russia was first to everything. Russia has Sputnik, first man-made satellite in orbit, first man in orbit, first animal in orbit, first woman in orbit, first spacewalk. It's all first. And you can hear JFK giving speeches. No matter how much money we throw at it, we're going to be second. And then suddenly, 1969, we're there. We surpass all of the Soviets' accomplishments, and we go and we land on the moon. Did we?
Have you ever seen off-ramps to freeways? So, off-ramps, have you noticed they have grooves in them?
Yes.
That's to prevent you from sliding off.
Makes sense.
If the road is a little bit slippery because it just rained or whatever. They groove the off-ramp, a curved off-ramp.
Mm-hmm.
So you say, who invented those grooves? That's brilliant. It's simple and brilliant. NASA did. Because the space shuttle, which comes in for a landing, does not have engines. It is a glider as it comes in for a landing, and it's got a parachute. It's got some brakes, but it's really got, so if there's a crosswind, that's hard to fight that. So those grooves help it stay on track, because it doesn't matter how you come in, the photo at the end shows how good a steerer you were. So some clever engineers decide if you groove it, then the shuttle can stay on course more tightly, and that was then borrowed for the freeway system.
How are black holes formed?
That's a good question. They're formed at the end of stars' lives, or at least the smaller ones are. So what happens when a star is burning its fuel, like the sun is now? What's happening is that the sun is carrying out nuclear reactions in the core. They're called nuclear fusion reactions. That releases energy and that keeps the star up. But the star is burning a lot of fuel. The sun is burning, let me remember the number, it's 600 million tons of fuel every second. Hydrogen fuel can burn it into helium. So that can't go on forever. In the sun's case, it'll last for about another 4 or 5 billion years. When it runs out of fuel, then gravity will take over and the star will start to collapse. And if the star's big enough, there's no known force, even the rigidity of matter, that will stop it collapsing. So it collapses and collapses and collapses,
and forms a black hole.
Line up 1,000 people and have them flip a coin. And if you get tails, you sit down. In a classic execution of this experiment, there's one person left at the end. And you know something? That person flipped heads 10 consecutive times. So what does the press do? The press goes to that person. Say, how do you feel about winning this coin toss? You know, I felt some heads energy halfway through. This felt really real to me. And I saw signs, so I knew I was going to win. Did they interview anyone else who didn't win to see if they had heads energy feelings? No, they don't even get interviewed. And plus, we are so hubristic and ego-driven that we think we are special for having flipped head 10 times in a row. When almost every time you do this experiment, somebody's going to flip heads 10 times in a row.